Long division. Use long division to simplify 3x cubed minus 12x squared minus 9x plus 1, and we're dividing by the expression x minus 5. Okay, so I want to remind you of a few key terms. The term in the numerator is called the dividend, and the term we're dividing by is called the divisor. But to compare this to a problem that you've done a long time ago, the first time you did long division. You did it with numbers, right? Let's compare it to something like this. 473 divided by 6. Well, when you were doing this a long time ago, you would rewrite it in this form using that notation. So we're going to do exactly the same thing because look, the 473 is the dividend and the 6 is the divisor. So we can do something similar here. We can take our dividend, 3x cubed, minus 12x squared minus 9x plus 1 and divide it by x minus 5 by the divisor. Okay, so working the problem with numbers, you start out saying 6 times what gives me 4? Well, nothing. 6 is bigger than 4. So then you moved over and you included an additional digit. 6 times what gives me 47? Nothing. Okay, well 6 times what number gives me a number really close to 47 but smaller? Well, we know 6 times 7 is 42, so we put a 7 up here. Then we multiplied and put the answer down here. So we're going to do exactly the same thing. X minus 5 times what gives me this entire expression? Well, that's a lot to think about. So we're going to use this example over here. We didn't say 6 times what gives me 473. We started with the piece at a time. So x times what gives me 3x cubed? Well, how about 3x squared? And notice I'm lining up the x squared above the other x squared. So 3x squared, and then we did 7 times 6, and we multiplied, right? And put the answer below. So we're going to do 3x squared times x minus 5, but again, be careful, because you really have 3x squared times 2 terms, so we have to distribute. So when we do that, we get 3x cubed minus 15x squared. So you're going to take this 3x squared and multiply it by the x, and then multiply it by the negative 5. So we're going to get, as I said, 3x cubed minus 15x squared. Okay, then when you were doing this problem, way back when, this one, way back when, then I'm going to erase these arrows because they're kind of in the way. Then you came through and you said, you know what, I'm going to subtract. We subtracted right here. And then you did 47 minus 42, you got a 5. So we're also going to subtract in this step as well. We have to be careful. We're taking this expression right here and we're subtracting this expression. Notice the expression that I am subtracting has more than one term. So I need to be really careful that I subtract all of the terms. Okay, so what I'm doing here, I'm just going to write it out here, is 3x cubed minus 12x squared minus 9x plus 1 minus 3x cubed minus 15x squared. If I leave it like that, I'm only subtracting the first term. But I'm actually going to subtract the entire expression. So I need to use parentheses. And then when we were actually solving this, if we wrote it out in this way, we would distribute a -1 or a negative sign into that set of parentheses. Well, what happens when you distribute a -1? You change all the signs, right? So that's what we're going to do over here. We're going to come over here and just change every sign. I'm using a red marker to indicate that I'm doing that. So that's how we're going to subtract. So notice these will cancel. Then we get -12x squared plus 15x squared. Signs are different, so I'm going to subtract. So 15 minus 12 is 3. I still have the x squared. I'm going to use the sign of the bigger one, so positive. Okay, and then when you were working this problem over here, 47 minus 42, we got 5. The next step was to bring down the remaining term. So then you had a 53. So we're going to do the same thing. We're going to bring down these terms. So now we have 3x squared minus 9x plus 1. Then looking back at this problem, we did it again, right? 6 times what is 53? Well, nothing. So 6 times what gives me a number smaller than 53, but it's pretty close. How about 8? Because we know 6 times 8 is 48. So I put a 48 here, and then we subtract. So we're going to do the same thing here. We say x times what gives me 3x squared? Well, how about plus 3x? And then again, we take this plus 3x and we multiply by the x, and we multiply by the -5. So we get 3x times x is 3x squared, and 3x times -5 is -15x. Okay, and then we come through and we subtract, which means we change every sign. And then we combine, right? So 3x squared minus 3x squared, those cancel. And then we have negative 9x plus 15x. The signs are different. So we're doing 15 minus 9, which is a 6, so we have 6x. And we use the sign of the bigger one, so we actually get a positive 6x. And then, as we did in the example with numbers, we're going to bring down the rest of it. So plus 1. And we do it again. So we have x minus 5 times what gives me 6x plus 1? Well, x times what gives me 6x? We're going to say plus 6, and then we're going to take this plus 6 and multiply by the x, multiply by the minus 5. So we get 6x minus 30. Then we come through and we change every sign because we're subtracting that second expression. When we do that, 6x's cancel, we get 31. Okay, so let's go back to our problem with numbers over here. So when we did this division, we ended up with a 5 down here, and notice that 6 is bigger than 5. So probably the first time you did this, you may have written R5, R meant remainder. And then later you said, you know, we're not really going to write it that way anymore. We like fractions. Fractions are fun. So then we said, take the remainder and put it over the divisor. So 78 and 5/6. So we can do that here. I'm going to extend this line. We write the remainder plus 31 and we put it over the divisor. Okay, so I'm going to write this in several different ways so you can really see what we're doing. So if I start with the original problem, write it in the same form with this fraction. Now we see that's equal to 3x squared plus 3x plus 6 plus 31 over x minus 5. It's a true statement, right? Okay, I'm going to scroll down just a bit. But what if we want this as an equation with no fractions in it? So if I want to, I can multiply through by the least common multiple of the denominators. And you can see this piece doesn't have a denominator. It's really interesting. It really does have one, but it's over 1. So the only denominators that we have are actually the same one. It's x minus 5. So we're going to multiply every single piece of that equation by x minus 5. So I'm going to multiply this one by x minus 5. It might be helpful if I write it over 1. Okay, and now we can see that hopefully all of the denominators will cancel or we mess something up. So I have an x minus 5 in the numerator, cancels with this x minus 5 in the denominator. Notice these denominators are just 1, nothing to cancel. Here I have an x minus 5 in the numerator, and that cancels with the x minus 5 in the denominator. So now we can rewrite this. Okay, so let's label our pieces again. Do you remember what this one was called? This was the dividend. And we divided by x minus 5, that's the divisor. New terminology. This piece is the quotient. And then this guy is the remainder. Okay? So let's verify to actually see if we get this is really the right answer. So what I'm going to do is expand this. Okay? Is this true? So what we're going to do is we're going to distribute. We're going to take x times everything in the back. Okay, when we do that, we get 3x cubed plus 3x squared plus 6x. Then we're going to go through and we're going to take the negative 5 times everything in this back expression. And I'm going to go ahead and line these up so they're easy to combine in a moment. So negative 5 times 3x squared, that's negative 15x squared. And then negative 5 times positive 3x, that's negative 15x. Then we have negative 5 times a positive 6, and that's a negative 30. Then we're going to add 31. So this 31 right here, I'm just going to add 31, and then I combine this. So we get 3x cubed, and then I notice I have the x squareds all lined up. So I have 3x squared minus 15x squared. That's negative 12x squared. Look, the x's are all lined up. So we have 6x minus 15x. That's negative 9x, and then we have the constants all lined up. So negative 30 plus 31, that is positive 1. This is the same as this. So this is correct. I can erase these little question marks and say, yes, this is true. Okay?